Looks like my live.
All right, you gonna switch to me?
Yeah. There you go.
Hello, and welcome to the Ubuntu Online Summit, Day 3, November 2015. My name is John Grimm. I am the engineering manager for the Ubuntu server team, and we have another presentation today by Stefan Graber and an introduction to LXD, the container hypervisor. And I'll just turn it right over to Stefan.
Okay, thank you, John. Switching that over to slides over here. Okay, so as John mentioned, I'm Stefan Graber. I work as the technical lead for LXD on the canonical server team. I'm also the LXD project leader and Lxe project leader. In this session, I'll be introducing LXD, what it's about, bit of history, where we are right now, where we're going in the future, and giving you a demo as well as showing you some new cool stuff with Lxe Cli just landed. So first off, a tiny bit of history. LXD, so we're talking about containers here. History of containers roughly goes as things started around 2000 with Virtuoso done by Parallels. I'm not sure what they were actually called Parallels back then, but those guys. They did Virtuoso as a way of doing Linux containers on Linux, similar to BSD jails and several zones. That first implementation was closed source as that Virtuoso product out there. A year later, the Linux vServer project started and basically did an open source implementation for Linux of containers as a massive patch set against the Linux kernel. A few years later, Parallels decided to open source most of their Virtuoso product as something called OpenVZ. That's still alive today. It's also a pretty massive patch set against the Linux kernel, which gets you containers with live migration and all of those cool features. Now, everyone involved figured that none of those patch sets were going to make it upstream anytime soon. They were way too big, way too complex in touching various subsystems that would never accept those kind of patches. So come 2008, after discussions with the different kernel maintainers, comes LXC. LXC stands for Linux Containers. It was started as a new user space project to interface with upstreamed container implementation. So LXC was designed to only use features that were actually upstream, not depend on any patch set. It's so basically mean that LXC, as it started, was pretty minimal. A lot of the security features weren't there. You couldn't attach inside an existing container. It was trivial to escape a container. Resource limits were pretty minimal. Doing a reboot inside a container would reboot your physical host, that kind of stuff. But it evolved quite a bit over the years. Canonical got involved around 2009 in LXC upstream, at first by just contributing some fixes here and there. Then we started maintaining our own branch of LXC, which was called the LXC staging branch. That was done upstream, and that branch would then feed into the actual LXC release. That lasted till 2013 or so, where Serge Allen and myself were appointed the new LXC project leaders by then project leader Daniel Lescano. And we've been maintaining LXC upstream ever since. For us, our main milestone was February 2014, so right before Ubuntu 14.04 LTS. We tagged LXC 1.0. It was our first production-ready enterprise class version of LXC, coming with 5 years support. We've been doing bug fix releases for 1.0 every couple of months or so, basically backporting every single bug fix which hits our development tree. So that was great. We had an LXC that could be used in production. We were offering a stable API that people could build their tool on and bindings. And in fact, you can use the LXC library in pretty much any language you want today. However, because of LXC happening through evolutions rather than design of its final set of features, it meant that the default LXC experience, in order not to regress existing users, has been stuck basically, well, pretty similar to what it had at the beginning. That is, we are not using all the available security features in LXC by default, because doing so would probably break some users on upgrade. Our command line API interface is not as great as it could be, because there again, it just grew kind of organically. And fixing either of those issues would basically break all of existing users. So that's when we basically came up with LXD. LXD is a new container management tool. We call it Container Light Advisor, and let us fix a lot of those issues by coming with a new user experience from scratch, new tool from scratch that can be designed to be simple, easy to use, clean, and secure by default. So what's LXD? Well, I touched on some of those aspects like a few seconds ago. It is designed to be a clean command line interface talking to a daemon that provides a simple REST API with pretty clear terminology. It is fast because, well, those are containers. We're not doing virtualization. We're not using any virtualization extension at all. So it's basically a set of processes running straight on your kernel. You don't have any visible overhead when accessing resources from those containers. Now, it's, as I mentioned earlier, it's secure by default in the sense that we use every single kernel security features available. We do user namespaces by default, which was the main feature we couldn't really set as a new default in LXC. We are also doing seccomp AppArmor capabilities and C groups to restrict access even further. And it's scalable. The exact same tools, exact same daemons, exact same APIs can be used from just running a few containers locally on your laptop for development to doing a mid-scale kernel deployment where you have maybe a few hosts running staging services or something within your company, to scaling to a whole private cloud based on OpenStack. That's basically what a normal good representation of what LXD looks like. So you have a bunch of machines. I mean, if it's just your laptop, then you just got one. But you can have X number of hosts. They all run the Linux kernel. They all run LXC through liblxe. And then LXD sits on top of those and exports a REST API. And we then have, sitting on top, a few clients that you can use. Nova Compute LXD is our OpenStack client. So if you load that plugin into your OpenStack, then you can manage containers just as you would VMs. It's completely transparent from your point of view. And we are also shipping a command line tool called Lxe that will let you interact with LXD containers. And as I mentioned, our REST API is meant to be simple and stable. So it's pretty simple for you to write your own client. You can either do it directly using the REST API, or you can use one of our bindings. We currently have a Python and Go binding. So a few things that LXD isn't. I did already mention that we're not another virtualization technology. We do not use virtualization extension. We are, however, looking at using hardware features to enhance security where it makes sense. So as a result, we're in talks with a few other manufacturers looking at what they can provide us to further improve container security without turning those into virtual machines. It's also not a fork of LXC. LXD, well, the LXC project is still well alive and will be maintained for years. In fact, it provides the library on top of which LXD is built. We see LXC as a really good low-level container manager that people can easily script, can easily build their own solution on top of. And for some users, also directly interact with using our old command line tools. LXD just sits on top of that. Any feature that we need in LXD is first implemented in the LXC library so that we can then use it down in LXD. And importantly, LXD is not an application container manager. To expand a bit on that, Docker, Rocket, and other similar technologies are what we call application container managers. They run a single application. They configure the environment for it. They can do things like setting up network and NAT rules and all that stuff. But ultimately, they run a single process. And when that process dies, they consider the container as being dead, and you can then respawn it. It's great for microservice kind of design, but it's not what we are focused on with LXD. LXD is designed to offer the same user experience as you would from a VM. So we're running a full Linux distribution inside LXD containers. We're running, but yeah, it's basically a completely unmodified version of Ubuntu or of any distro you want to run inside it. We will fake resource limits as appropriate so that you can limit memory, CPU, and whatnot, and you get the right looking files and stuff inside the container so that it makes sense. So our goal is really to offer a VM-like experience using containers. As far as we are concerned, Rocket and Docker would be great things to run inside a LXD container. We don't see those as competition. They are a completely different concept. Now, LXD at scale, that's an interesting thing because one of the clients that we are working on is an OpenStack plugin. If you install that into your existing OpenStack, you can manage containers just as you would VMs. Any tooling that today interfaces with your OpenStack will then just interface with LXD containers transparently through OpenStack. Using containers within OpenStack makes a lot of sense if a lot of your VMs today are both running Linux on Linux, which is obviously the requirement for containers, and are mostly idle. VMs have a pretty high cost for idle workloads in that you do need to context switch to them pretty often. You do need to process interrupts. You do need to process a whole lot of things, even though the VM is not actually performing any work. Containers, on the other hand, don't have that kind of problem. They do not, like the kernel itself will deal with interrupts and all that stuff. We don't waste much resources dealing with stuff coming from running but not actively working containers. The other thing is direct hardware access. Containers, you can literally just pass any block or character device straight to them. You can pass any network interface straight to them. You do not need to fake hardware or pass a full PCI device, any of that stuff. And any such access will happen without any overhead because, well, the task inside the container just talk directly to that thing. And lastly, compared to VMs, we obviously have a negligible overhead. I'm not saying no overhead because we do apply some resource limitations through C groups, seccomp, and other managed access controls. Those do have a tiny overhead depending on what kind of syscalls you're doing. However, if what you're doing is not does not involve syscalls, then we have no overhead because you're talking straight to the physical CPU. It don't go through any kind of level of interaction anyway. And now to the interesting part of this whole exercise. So one thing we've been working on lately, and let's see if I can get myself out of there. There we go. So we've been wanting for a while to make it extremely easy for users to try LXD. Initially, we've been doing that with PPAs for Ubuntu releases, trying to make it easy for people to install it. But we figured there was an even better way, which is, just go on a website from any web browser that you might find and get yourself a temporary LXD you can play with. So that's what we have here. It's available on our website. Let's see if I can make that thing go there. The URL up here is linuxcontainers.org/lxd/try-it, or you can just find it from the LXD menu on the website. It's a web service that we have, which will get you a container for certain minutes, in which LXD is installed, so you can easily interact with LXD. You can also start more than one of those and then have them all talk to each other, which is what I'm actually going to do right now. So first thing I'll do is start 3 of those containers. So that's 1, that's 2, and that's 3. See, I get a console right here. That's great. There we go. Just installing one package that I need later on in the demo. JQ is a JSON renderer for shell, which makes it pretty nice to see JSON data. All right, so I've got 1, 2, 3 containers running. Just scroll down a bit so people can't easily see the credentials. Oops. And that's the first one. Okay, so LXD is entirely image-based. We no longer have any of that funny shell script creating container stuff that we used to have in LXC. You can list images available in your local LXD with LXC image list. First time it connects, it generates a new SSL certificate that's used for authentication later on. We see that on the demo service, we pre-seed things with an Ubuntu 14.04 LTS image. It's got a fingerprint that you can use to compare and make sure that you've got the same everywhere. And it's got a friendly name that you can use to start it. So starting your first container, you can just do Lxe launch Ubuntu, and let's call it first. And there we go. Container is started. If we list it, we see it's first, it's got an IPv4 address and IPv6 address, and well, it's running. Now you can get some more information on it with Lxe info. So Lxe info first shows basically the same thing plus the PID of its init process on the host. It can be useful for some kind of scripting. Now you can look at the container configuration with Lxe config show. And well, it's the default configuration. We see the default configuration profile is applied. We see what image the container came from, what's the MAC address that was generated for it, and some information, some internal state for ID mapping. Now, by default, we do not apply any resource limit. So if I look for how much memory I've got, we see 256 megs, which is what the host, in this case, the container we give you on the demo service. So we see 256 megs for each. Now, I can change that with Lxe config, set first, limits memory, and say 64 megs. Then restart that container. The restart step is going away really soon. It's just a temporary thing here. We'll apply all resource limits live. And can check, and the container now has 64 megs. Most of which are used because, well, Ubuntu 64 megs is maybe stretching it a bit. Anyway, now that that's done, we can exec other commands in the container. So here I'm just running a simple apt-get update. Okay, then let's list upgrade that thing. I'm sure there's some updates pending. Alrighty. Oh, and while that's going, all that you're seeing right now is actually, for more than not, the So what you see in the web browser is actually a JavaScript terminal talking over WebSocket to a LXD proxy, which talks to a LXD, which backs those instances we start on the triad service. Then inside the console I've got right now, whenever I execute a command, say auto remove right now, that's actually running against, well, that's running against a container running inside there, but that's also doing so over WebSocket and REST API. So we do not special case interacting with local LXD, really. It's still talking over REST with the same API you would for a remote server. And there's actually one small difference. When you're interacting with your local LXD, we do not do HTTPS and SSL sort of authentication. We're just using a Unix socket. And so long as you are a member of the LXD group or your root, then you can just interact with your local LXD. So that container is now upgraded, and I've cleaned all the extra packages and stuff that's inside it. So it will be a good time to snapshot it, because that container is pretty nice now. So snapshot it and call it clean, which is done. And now let's say I'm doing something pretty stupid, which is wipe all of itsy and all of user in that container. At which point, if I execute, say, bash, you'll say that I've got a problem because I no longer have a name, there is no more itsy, and if I was to run anything that was in user, then it wouldn't quite work. But I can easily fix that. I can do restore of that snapshot. There we go. Get back inside, and hey, everything is working again. And you might have noticed how quick that is. Now that the other thing is, so we've got that container running here called first, and we see we've got a snapshot called clean. That's great. Now, what if I wanted to share that and make it possible to create more of those same containers on multiple hosts? Well, what you'll probably want at that point is turn that snapshot into an image. So that's the publish command. You can publish the clean snapshot of the first container as an image that's got an alias called clean-ubuntu. Run that. It's going to take a little while because it's actually doing a full tarball of that container and compressing it, and then hashing it, and you'll get the fingerprint, which is your unique identifier across all of your hosts. Hopefully not much longer. Come on. Yeah, so we actually now have a way of setting the compression level for those images. By default, we do gzip because it's reasonably quick. In the live service, we actually turn off compression entirely, so it's basically just a pin tarball. That's because the demo service has pretty limited CPU and memory limits per container. So if we don't want it to take half an hour, it's a good thing to have that stuff turned off. Anyway, the image has now been published. We've got its full hash. If we look at the image store, we see we've got a clean Ubuntu image here with the same fingerprints that was just listed. And we can now, say, delete that first container. There we go. Now that the container is deleted, let's say we want to just create a new one from that new image. So clean Ubuntu, call it second, and there we go. We got a new container. The other nice thing with the REST API is, and LXD, is we can easily interact with the container file system, even if, say, the container's network state was broken somehow. So, whoops, it's called second now. So if I get a shell inside that container, I look, I've got networking, that's great. Well, whoops, I want to get down. Well, now I don't. So you see that the shell still works fine because we're not actually connected over the network to that container. We're just injecting a shell inside it. And now same goes for pulling, say, log files. So I can pull log syslog and just dump it to sedat. And we see the syslog for that container, even though the container has no kind of connectivity anymore. So that's great to debug your container, figure out what happened, restore connectivity, or if you're paranoid, you can actually run tasks in containers that have no kind of network connectivity whatsoever. And we don't need that container anymore. So all I've shown you so far is interacting with your local LXD. So pretty much all of that you could have done with some combination of the existing LXC command line. But that's not where the LXD magic is. We've got a command called Lxe remote, which will show you all the LXD host or image servers you're interacting with right now. By default, you're going to see the exact same thing that you can see here, which is you just have a local remote talking to Unix socket, and that's what LXD will, the LXC command line tool will use by default. Now, to make things interesting, you can add an image server. So we do run an image server at images.linuxcontainers.org. Those are community-built images. Oh, that's great. Did I typo somehow? Oh, never mind. Seems like just a temporary issue. Anyway, images has been added now, so we've got a new remote server we can interact with. So instead of doing just Lxe image list, which lists your local images, you can do Lxe image list images column, which will list the remote images now. So you can see we've got a few for CentOS, Debian, Oracle Enterprise Linux, Plano, Ubuntu, Gentoo, Fedora, and a bunch of others. Some of which may or may not be available depending on your version of LXC and some other things. Now that that's done, we can say, hey, I want to use one of those images. So we say it's on that image server. The image name was CentOS/7/AMD64, and let's create a container called third based on that image. Now, what happens here is the command line tool is talking to your local LXD. It's telling it, hey, go talk to that remote image server, pull that image I just told you about into your local cache, and then start a container from it. The cache is designed so that entries will expire a number of days after they were last used. By default, it's 10 days. So 10 days after that CentOS image is last used, LXD will just remove it from its local cache automatically. Taking a little while to download that image, it looks like. There we go. So the image was downloaded. If we look at our local image store, we see a new entry that doesn't have any name here, but has a fingerprint of 9BF something. That's the CentOS 7 image we just started. It's 56 megs large. It's stored in the local image store, and we've got a new container called third that's started. And I'm inside that container now. And if I look at, say, etc red.release, we can see it's CentOS 7.1.1503 container. Same goes for any of the other images we've got on there, so you can play with a bunch of different distros. Now, that's great. That's interacting with a local remote image server. But that's not where things get really interesting with LXD. What you typically want, well, will want anyway, is manage multiple LXDs themselves. So we see we just have that public image server added and a local LXD. But earlier I started 2 more LXDs, so let's go and get those credentials. So I get the public IP of the other container. Let's call it LXD01. Sure, let's accept that certificate. And oops. Enter the password, and OK, LXD01's been added. And now wants to add the second one. Let's call it LXD02. It's going to be this one. Well, There we go. So I've now got two more remotes here. We've got LXD01, LXD02, both talking of HTTPS to the other two demo instances I've started earlier. Now that that's done, I can list the containers on those two. You'll see they've got none, which is to be expected since they are completely fresh instance. And I can now also list images available on those. Just like my current instance, it's got the Ubuntu 14.04 image preceded. Now, what you'll want to do is say, hey, if you've got that local image that we created earlier, it's called clean-ubuntu, and let's say I want to create a new container that's called forth on that LXD01 server over there. So when you do that, it's going to tell LXD01, hey, want a new container. It's based on that remote image I've got here. There is a secret token you can use to grab that image. LXD01 will grab the image, will store it into its own store, will unpack it, and then we'll create a container from it, which it just did. And as we can see, we've got a container called forth running on LXD01 with its own IPv4 and IPv6 addresses. Now, if you want to get into that container, well, you just do lxe exec LXD01 container name, and then the command you want. And there we go, we're inside that container. So as I said, the experience is absolutely identical to dealing with local containers. The only difference you might notice is some latency. But from a code path on our side, it's absolutely identical. Now, I can say make a copy of that container. So I'm copying LXD01 container forth into LXD01 container called fifth. There we go. But maybe now I'm realizing actually I didn't want it on LXD01. So I'm going to move it from LXD01 to LXD02. So now it's instructing LXD02 to go talk to LXD01 with a secret token to export the container in question, transfer it across the network, and then unpack it locally and restart and set up everything up, then wipe it from the source. With a running container, if you have CRU and the right kernel and the right bits, which is pretty difficult, at least until 16.04 is out, this will happen with live containers as well. So if they are running, you're going to get live migration. Your tasks will just keep running. In the demo environment, and as it stands right now for what we've got in the Ubuntu archive, you can only move containers when they're stopped, because live migration is still work in progress. Anyway, that container was moved from LXD01 to LXD02. Now let's say I want to remove it, to rename it. So if you want to rename something, it's a move, just moving it on the same host. So in this case, you're moving it from LXD02 called fifth to LXD02 called demo. And there we go. We can then start it. And we can get a shell inside it. It's still called forth because, well, it wasn't reset or anything. It was just the container itself was renamed. Its internal configuration state wasn't changed. And we see we've got all of the usual Ubuntu 14.04 processes running, and apt update and all that stuff works fine. And just for kicks, we can check that we indeed don't have any update because it's based on that clean Ubuntu image that we created earlier. There we go. And that's basically the extent of the commands we've got to interact with LXD containers right now. The LXD backend itself can store containers on a variety of file systems with a variety of features. We recommend our fast and, to some extent, clever backends, which ideally is ZFS. BurFS offers the same set of features, and we also support it at the small issue that BurFS is not quite production ready, as in the file system is not. Our support is. LVM is also supported, and if you don't have any others, then we fall back to just plain directory and tarballs, which works, but is much slower than what you've seen right now. The triad service, so the demo service we're running, is using BurFS as a backend to make it really simple and fast to manage your containers. Now, that was using the command line tool. If you wanted to play directly with the API, you can do so using curl. So what I'm going to do right now is just tell my local LXD that, hey, I trust my client certificate. Just so that curl can work properly, I'm also going to launch a new container called demo based on a clean Ubuntu image. There we go. And now is the pretty long curl command. So I'm basically instructing curl to use the client certificate that the LXC client generated, as well as its key. And then I want to interact with the local LXD and say pull the service root at 1.0. And there we go. So what we see here is basically the server state. It's pretty much identical to what you would have got if you did config show, except it expands on some more details. Actually, no, it would be identical to Lxe info. Yeah, there we go. So what curl shows is what kernel is running, what version of LXC, what version of LXD, the server PID, the storage backend, and version of the storage backend, what addresses it listens to, its configuration, whether the client is trusted or not, etc. That endpoint is basically what you want to use as a sanity check that everything is working properly when you're scripting around LXD. If you wanted to list the containers, then you can query /containers. And here we see we've got a single entry that's containers demo. You can then query that. And here you'll see the container configuration. Expanded configs, you see like its network configuration, MAC address, what image it was created from. It shows that it's not an ephemeral container, so it will not go away automatically when it's done, which is the default. You can pass that option at launch time if you want to. It's running, it's got its IP addresses. That's all great, that's what we expected because we started the container earlier. Now, the cool thing is you can also just query any file on file system if you want. So you can do /files for that container and then say path equals, I don't know, etc host. It's not going to be JSON, so we don't need to decode it. Just going to there. Oops. There we go. And we see the content of etc host. If you were to do a post at the exact put at the same address, then you would overwrite the file content, just like you would with the Lxe file push command. So yeah, we've definitely tried to make the API make sense as much as possible, make it obvious, not overcomplicate things. The structure is reasonably simple. It's pretty easy to script around with curl and even simpler to script around in any other language. And that's pretty much it for my demo. So as I said earlier, I did that whole demo using our live service, which means that you can watch that video or look at the notes that I'll post on later on. And you'll be able to run all of that by yourself to play with LXD on your own time. Or you can install LXD locally and actually play with it on your own system rather than using ours. Now, let's go back to the slides. This one. So, just getting my notes as well. Okay, so what's coming in next for LXD? The main thing we're working on, and we actually have Tycho Anderson working pretty much full-time on that, is live migration. It's supporting moving containers as they're running between hosts. We can currently do it with LXD. There's actually a migratable profile you can assign to your container for that, except that it's not safe right now. If the container is using user namespaces or is using seccomp, it will not be migratable, so we have to turn off those features before we can migrate the container. That basically means it's not production ready. But current work over the past few weeks actually means that current Creo, which is the tool we use for live migration, in Git is actually capable of live migrating safe containers. So we will be getting that in 1604. In 1604, you'll be able to move containers around. Some workloads will not be migratable, in which case you will get an error message at the time you try to move and not at the time where the task attempts to be restarted. So your service will just fail to migrate, but will not be killed in the process. We're also looking into improving our network and storage handling. Specifically for network, we're looking at making sure that SDNs work properly with us, specifically through Neutron and the OpenStack plugin. As far as storage, as I mentioned earlier, we do support any file system with our slow backend, or we support LVM, BRFS, and ZFS. ZFS is what we want to recommend people to use. We are going to make it even simpler to set up LXD with ZFS in the coming weeks. The other main thing, and I've noticed at least one question on IRC related to that, is resource limits. So what I've shown you earlier is memory limits. We also support basic CPU limits, both of which are applied to all of those demo containers that you can create for free, because otherwise people will just hog the old server pretty quickly. But it's not our final resource limit story. We do have a new clean design of resource limits, which is going to land over the next few months, which will let you do fine-grained CPU, memory, disk space, block I/O, and network I/O limits. That includes things like limiting IOPS on network and block, limiting memory with both a soft and hard limit for memory usage, involves CPU pinning as well as CPU priority, and soft and hard limits for CPU usage. And all of those will also be queryable, so you can get the current resource usage of your container. And resource limits will be applied live to running containers. You will not have to restart them. Obviously, if you setting a limit that's smaller than what the container currently uses will fail, but you'll be able to update limits of a running container so long as it's larger or larger than what it currently uses. We're also actively working, mostly Chuck and the guys working on Nova Compute LXD, in supporting all of the LXD features with OpenStack through our Nova plugin. That's been making great progress. What we have in 15.10 is actually pretty close to it. They even support migration and some of the other things that are not quite ready on our side, so that's great. They're already ready for it for when it actually lands in the working state. We're also working with Juju to support LXD containers. The story there is that we want Juju to use LXD instead of LXC as the local provider, as well as to set up containers within a VM in public cloud or private cloud, whatever, inside a cloud instance. And lastly, I did mention it earlier, we want to make sure that Docker is running properly inside a LXD container, so that you can deploy and give access to LXD instances to your users who can then deploy their services using Docker inside those. So a quick recap of all of this. So LXD is a simple but powerful REST API to manage infrastructure containers. Again, infrastructure containers are basically virtual machines in that we run a full Linux distribution. Not to be confused with application containers, that's the Docker-style container where a single task is running inside them. LXD is entirely image-based. We apply every single security feature available, as well as the user namespace in the kernel, which provides with a safe by design kernel container. That's why we call them trustable containers. LXD is scalable. A given host, like a normal laptop, can probably run a few hundred containers, typically way more than can VMs. And if you go to big iron kind of machines, it's not unusual to be able to run thousands of Ubuntu containers on them. And LXD has been designed from the ground up to be simple to use, make sense, and work at scale. So that's why we say it's designed with developers and enterprise in mind. It does work great locally to just manage your local containers, but you can also add 50 compute hosts to the same command line tool and still manage them. And if you get past the 50 or so point and you need something to manage all of those for you, then you can just use LXD with OpenStack and use the existing tooling and orchestration tools around OpenStack directly with LXD. And that's pretty much it for for this talk. One nice thing is contributing to LXD. LXD itself is written in Go. It's fully translatable. Unfortunately, we don't have much of a translation right now. So if you're speaking a foreign language and want to help with LXD, pull requests are really very much appreciated to add more languages to our command line tool. We have API clients in both Go and Python that are available. We will be reworking the Go one to be cleaner this cycle. So if you do use it, feedback will be very much appreciated, but also keep in mind that it will be changing. LXD is Apache 2 licensed, and we do not require a CLA. We do, however, require you sign the developer certificate of ownership. That's the standard signed off by line that you need to put in your commits, just to confirm that you do own right on your code and that your employer is fine with you contributing to a project. And it's available on GitHub, so you can git clone github.com/lxe/lxe/lxe, or just add on to that URL where you can look at our repository, file bugs, ask questions, etc. Just before wrapping up and taking questions, the website I've showed you, the URL is there again. It's linuxcontainers.org/lxd/try it. The code for it has also been published as of yesterday. It's on github.com/lxe/lxd-demo-server. So if you want to run your own demo server, you can look at that, and you can look at the code of our website at github.com/lxe/linuxcontainers.org to download our website itself and look at the JavaScript client we've got in there. And that's pretty much it for my demo. We've got a bit less than 10 minutes for questions, and I've seen a few being asked on IRC that John picked up, so that's great. John, do you want to fire us on?
Yeah. So first question was, do you think LXC as the name for the CLI tool is a bit confusing? What's the rationale behind that?
Yeah, it's definitely confusing when you've got both set of tools installed on your machine, which is unfortunately the case right now because LXD actually does pull LXC, which is unfortunate. We are going to be fixing that in 1604 so that LXD only ends up pulling the LXC library, so you have a single command line tool. The rationale for that is we want LXD to be the new LXC 2.0 experience. So while LXC upstream will still be maintaining the existing LXC tools, we will not be recommending people using those by default. Instead, we'll recommend people install LXD and get the new LXC user experience, which is that new LXC command line tool.
All right. Question number 2, and I believe you answered this already. Can you set resource limits such as CPU, RAM, disk, bandwidth on a per container basis for both from the API and from the LXC CLI?
Yeah, that's what I mentioned earlier indeed. We can currently set a number of CPUs. Even that is a bit flawed right now. And we can set a memory limit right now, both through the command line as I showed earlier with Lxe config sets limits.memory, or through the API by updating the container configuration over the API. But all of that is going to change pretty soon, even though those two, the name and their value will actually stay the same, but we'll be adding a lot more limits and knobs and stuff that people can interact with, including what we don't have today, which is network I/O limits, block I/O limits, storage size limits, and yeah, fine-grained memory and CPU.
All right. Question 3. Will it be possible to push from the local without having LXD exposed? As I understand, pushing to a remote basically pulls from the local LXD.
That's Correct. And right now, no, you can't. We do have a plan, but it's not something that's been prioritized very high right now, to basically make our command line tool clever, in that it will detect whether two hosts can talk to each other, and if they can't, then the client itself would act as a proxy and forward the data across. That's the idea, and it will be nice to work around some firewalls as well in some environments where you have like strictly separated staging and production environments, but you have sysadmins that are supposed to move things between the two. That feature will be great for that, but it's not something we've implemented right now.
All right. Next question. How does LXD order networks when containers have multiple physical networks?
So we don't really do ordering in the sense that it's similar to LXC in that you can specify a device name. If you do, say, for example, our default editor config comes with if0. It's actually said if0 in the config, so it's guaranteed that the container will have that device called as such. If you do not set a name, then we let the kernel pick whatever it wants, which typically will mean it's going to take them in alphabetical order of the device entries in the LXD config.
All right. Just a couple more questions. Can we steady reproduce the Ubuntu images published on images, linuxcontainers.org? Is there a public method to build them from stock Ubuntu releases?
Yes, so actually those images are built entirely publicly. So the way they are being built is using a set of tools that's available on GitHub in the LXC-CI repository. That's being called daily, so it's the build image command. That's being called daily by our Jenkins server at jenkins.linuxcontainers.org. You can see the console output and all of that there. Then it's being pulled by our image server, signed and published. Note that those images are, however, not the images we would recommend for Ubuntu, and those are not the images I actually showed you today. The images we do use for Ubuntu are currently imported over SimpleStream by the LXD-images command, and those are the exact same bit-for-bit CLUD images as are used by a set of different tools, and published by Canonical on cludimages.ubuntu.com.
Great. And our final question. Is there an idea to work on a connection to the libvirt ecosystem, and will LXD exist pure in parallel and more tight to OpenStack? Libvirt can do some things LXD does not, I think.
Yeah, so no, I'm going to answer that in a few different ways. So first of all, we have no intention to integrate LXD with libvirt. A good part of the reason why LXD exists is because libvirt is great at managing virtual machines, but it's API and it's not designed for containers. So LXD instead takes a view where we are dealing with containers, and there are features that we can make use of, say pulling IP addresses from the container, injecting commands inside it, push and pulling files, etc. All of those container-specific features, we want to have them front and center in our tools, so that's why we basically design LXD around those. Now, as far as OpenStack, it seemed odd for us to have to go through OpenStack, then Nova, then libvirt, talk to LXD, that then talks to LXC. That was like pretty indirect. And also because of libvirt not exposing all of those container knobs, it wasn't a good fit. So it was way simpler and much more powerful for us to write a straight Nova plugin. So we're still using Nova, but Nova, instead of doing Nova libvirt, we do Nova LXD, and we go straight to the container, bypassing libvirt entirely in that case.
All right. And one quick follow-up right before we run out of time. How would one currently push a locally developed image when you're behind a firewall?
I'm not sure what you mean by push in that case. So we do not have a public image server that you can push stuff to. We do not have a Docker Hub kind of thing, because it's tricky from a legal perspective to actually know that you are respecting the GPL and DOR licenses for those images. And because we want to recommend people use clean images from their distribution, they might modify them locally, and it's perfectly fine to have a LXD server on your local network that's acting as your local image server, in which case you would just run one such LXD on one of your local hosts, add it as a remote to whatever clients you're managing your network with, And then you would push your image to that server using the -- public flag so that any host on your network can pull that image unauthenticated. And I think we're running out of time. We've got like a minute left. And
I believe that's true. And no more questions, so I think we're good.
Perfect. So I guess that's a wrap.
All right. Thank you, Stefan.
Thanks, everyone. And yeah, if you want to ask any more questions, feel free to hit me up on any social media, or you can go in the #LX containers channel on Freenode, where all of the LXC and LXD teams hang out. We also have mailing lists and many other ways for us to contact us. All of those are listed on our website, so just go on linuxcontainers.org and you can get it from there. Thank you.